For this question, we are asked to approximate the area that is bounded by this function and the x-axis on the interval from 1 to 5. So I'm going to start by marking that interval from 1 to 5 on my graph. So we're saying start here and end here, and between the x-axis and the function, there is some exact area that is bounded. But what we're going to do is approximate it by using rectangles. Rectangles have a simple formula, so it'll be very easy to get an approximation for the area. And it tells us to do it in two ways. We're going to use left and right Riemann sums. So I'm going to start by doing the left Riemann sums. That's a very fancy term, but the idea behind it is going to be very simple. So here's what I mean. For this interval, from 1 to 5, they say divide it into 4 subintervals. For these numbers, that's pretty easy to do. You're basically going to count by 1. So here's one subinterval, here's the second, third, and fourth. So here we have 4 subintervals that will be the base of a rectangle. If we start with this very first subinterval from 1 to 2, and we're going to compute a left Riemann sum, the left is telling you, take this left endpoint, go up to the function, and construct a rectangle. So I'm going to draw that in there. Now, the area of this rectangle is not exactly equal to the area under the curve because you're missing some stuff, but we're talking about an approximate value, so it's going to be kind of close. So to start our approximation, step 1 would be, well, what is the area of this rectangle? So the base is 1, and we're going to multiply it by the height, which is 4. So the area of this rectangle is 1 times 4. The 1 came from the length of the base. That's one of the subintervals. And the height, 4, actually just came by using the graph of the function. You want to complete that for the remaining 3 subintervals. So what we'll do is add on the next one. For this next subinterval going from 2 to 3, again, we're talking about a left Riemann sum, so we're going to use a left endpoint. For this one, if you go up to the function, it's going to go up to here, which is a y value of 7. And then we'll go over and down. Okay, I want to add on the area of this, and now this. The base, it's still 1, but the height this time is 7. So again, it's a base times a height, and now we just add on a second base times a height. If we continue in this fashion, okay, we now have to focus on our third subinterval from 3 to 4. We're talking about a left Riemann sum, so I'm going to use a left endpoint, and I'll go up to the function, which is right here. So we start down here, go all the way up to the top, which is 8, go over and down. So this is going to be the base is 1, the height is 8. We're almost done. I'm now going to add on that last rectangle. So for this subinterval from 4 to 5, again, the base is 1, so I'll put that down. But the height is 7, so right here. And let me write in that 7. So the thing to point out is that if you add up the area of these rectangles, you'll get a number if you compute this thing down here. But the area of those rectangles, it's not exact, but it's pretty close. It's a decent approximation to the exact area under the curve. The reason that it's not exact is because, well, the base of the rectangles were just a little bit too long. We either missed some stuff or we kind of like went over in a couple of places. So the last part of this problem is to simply do this computation out. The value that I get is 26. So again, this was a left Riemann sum, and all it's telling you to do is use rectangles to figure out or approximate the area under the curve. But you have a choice. You could either use like the left endpoint or the right endpoint, and the left just means, okay, use the left side of the interval. For the second part of this problem, we are instructed to compute a right Riemann sum to again approximate the area under the curve from 1 to 5. And it's going to be almost identical to what we did in the last problem. So you still have an interval from 1 to 5 that we're dividing into 4 equal subintervals. But this time, when we want to approximate the area, and we start with this very first rectangle, the base is going to be 1, but right means I'm going to use the value 2 as the right endpoint of the interval. So here's my base, and now the height is going to be this. And we get something different than what we had in the previous part of this question. The base is still 1, but now the height is 7. We've gone over what the actual area is, but again, this is an approximate value. If we continue, for this second interval, again, we're going to use the right endpoint, which is 3. So we go up to the function, which is going to be at 8. We go over and down. The base is still 1, but now the height this time is 8. For our next subinterval from 3 to 4, again, I'm going to use the right endpoint, which is 4. So I go up to the function, which has a height of 7. I go over and back down. Okay, so the base is still 1, but this time the height is 7. We're almost done because we're at the last subinterval. So we're going to go from 4 to 5, but I'm going to use 5 as my right endpoint. Okay, I go up to the function. It takes on a value of 6, so I go over and down. So the base is 1 and the height is 6. So the last thing to do, since I have a picture for this, I'm just going to, in my calculator, add this up and see what I get. Okay, the value that I get is 28. So it's like, what is the actual exact area? I'm not really sure, but what I do know is that it's an approximate value of the actual area.